Hey, Stat class. I want to do a video on the next section, which is section 6.2 in your textbook. It's more confidence intervals, but these distributions are slightly different. And there's not as many examples, exercise problems to do in the homework. So it's important that you try the examples that are in the chapter. I'm going to do example 2 for you, and then I'll do one of the problems for you to run through how it works. It's very similar to section 1, except for the way we find the margin of error is slightly different, and we have to use a different distribution table. So instead of finding a z-score, we're going to be finding what we call a t-score, and I'll tell you why, and I'll tell you how to do it. So it's very important that you go through each of the examples, especially example 3. Read through that one very carefully. Example 3 is on page 313. And there's a different chart that we're going to be using. It's a t-distribution chart. It looks like this. And we're going to need our calculator, because unfortunately for this section, for whatever reason, they don't find the average for you. And they don't tell you what the sample standard deviation is. So they make you find it, but I'll show you an easy way to do it if you have a graphing calculator. If you don't have a graphing calculator, you're just going to have to use the old formulas, and they are on page 312 in the yellow box. The average and the standard deviation formulas are there. So let's just start with example number 2. So example number 2 talks about coffee shops and how hot coffee is. And they talk about, they took a sample of 16 coffee shops, and they took the temperature of their coffees, and they found out that the average coffee was 162 degrees, and they took N was being 16 because they sampled 16 cups of coffee, and they had a standard deviation of 10 degrees. They're telling us in that problem that they want a confidence interval of confidence level of 95%. Well, there's two things going on here. This is a sample where there's no way to know what the population standard deviation is. So when do you use t-scores instead of z-scores? Number 1, for when the standard deviation for the population is not known. And as a rule, if the n is smaller than 30, we'll use t-scores, whether it's a normal distribution or not, and don't worry about anything else. If we got small ones, we're going to use it. Even if they're over a certain amount, if they're over 30 and you don't know the population standard deviation, we're going to use a t-score. But especially if they're under 30, we're going to use this t-score instead of a z-score. This is the formula for the margin of error, and we'll talk about how to find the t-score right now. So this is everything that they gave us in the problem right here in example number 2. So to find this t-score, we have to rely on two things. Number 1, something that they call the degrees of freedom, which is always our sample size minus 1. So in our case, our degrees of freedom are going to be 15. And this is going to sound complicated at first, but if you just follow along with this, I don't think it's too bad. Then you go to the t-score chart, which I think is on page A18 or something. It says t-distribution. And on the left side of this chart, I don't know if you can see if the numbers are too small. These are the degrees of freedom. We're going to look down to a 15, and we're going to slide our eyes over to the 95% confidence level. So 15 and 95 comes out to be 2.131. You could even pause this video and make sure that you can find that number, 2.131. So since the sample was 16, we're going to use the number 15. And we're going to look under 95, and it comes out to 2.131. So that's going to be my t-score right here that I'm going to use. Now I'm going to use that t-score in the formula that's for the margin of error. And I put that number in for t times s being the sample standard deviation over the square root of n, which in our case is 16, I did the calculations to save time, and it comes out to be 5.3. Then what I do is I take 5.3 and I add it and subtract it, just like last section, onto the sample average. So this here is the sample average that they've given us, or sometimes we'll have to find it ourselves. If I add that 5.3 to 162 and also subtract it, I have an interval right here. And what this interval says, we believe, which is going to be our statement, that the true population mean is somewhere in between 156 degrees and 167 degrees. So that we're saying that our average cup of coffee, we believe, and we're 95% confident, that our coffee is somewhere in between 157 degrees and 167 degrees. And this is how it works. The only difference is the T distribution table and using this degrees of freedom, and then using this formula for E rather than the one we were using in section 1. When do we do that? When the standard deviation for the population is unknown or the sample size is smaller than 30, when n is less than or equal to 30. If it's over 30 and we still don't know this, we're still going to use this t-score. Okay, let's do number 26. Number 26 in the book says, they're talking about grade point averages in colleges. So they took a sample of just 14 students, very small sample size, and they want to be 99% sure in their findings. And they give us, in number 26, they give us all these grade point averages right here. So what I did was, to make my life easier, I took them, and I'll show you that I put them, if I go to Stat and Edit, I put them in a list. I put them down here. And all 14 of them I put in this list. Then I go second quit to go back to my main screen. And let me show you how easy it is to work with this if you have this calculator. And write this down if you don't know the keystrokes. Go second list, because I want to do something with my lists, and I'm going to go over to math, because I want to do some math with that list. Then I'm going to go down to, I don't know if you can see this or not, I hope you can. I'm going to go down to number 7, which says standard deviation. So I'm just going to hit a 7, or you could scroll down to 7 and hit enter. And I want to, standard deviation of list 1, and list 1 appears behind the number 1. So I'm going to go second 1, and that will give me L1, and you can see in here it's giving me an L1. Close the parentheses and hit enter, and it tells me that the standard deviation comes out to be 0.87. So I just wrote that down. Standard deviation is 0.87. Now I got to find the average. So I go to second list again, go over to math, and the average is number 3. So I hit number 3. And I want the average, or the mean, of L1, so I hit second L1, and it puts an L1 in there for me. Hit enter, I got 2.51 about. So I put the average down as 2.51. That's all from my calculator. Now if I didn't have that, I'd have to add up those 14 numbers and divide by 14. I'd have to use the standard deviation formula on page, what page was that? On page 312 in order to find the standard deviation. But if you have this calculator, how nice is that? It does all that work for you. So we have this so far. We know that n is 14, so therefore our degrees of freedom are going to be 13. There's a whole reason behind that, but let's not worry about that for now. Let's see. So let's go down to 13 in our chart. I don't know if you can see this, if it's too blurry. 13, and they want to be 99% sure, so I go over. I get 3.012. I don't know if you can see that. So if I do 3.012, that's what I got for my t-score. Pause the video and make sure you could do that. In the t distribution table, you go down to 13 because our sample was 14, and we go 13 minus 1. And then we look over underneath the 99% column, and we get this 3.021. Make sure you get that. Now I just put it in the formula right here, and I did the calculations for us, so I got a 0.7. 0.7, if I add it to 2.51 minus 0.7 and 2.51 plus 0.7. Sorry, my wife is talking to her sister and they're talking really loud. So if I subtract it and I add it on both sides of this, now I have my interval. So we're 99% confident that the true population mean of all the grade point averages is somewhere in between this 1.81 and 3.21. Go through the process again real quickly. So we have our sample size. We look in the t-distribution chart under 13 and under 99%. Go down to 13, look over to 99. And we got this t-score instead of a z-score. Why a t-score? Because this was smaller than 30. So we put it into our formula from up here, and we got a new margin of error. We add and subtract that margin error to the sample mean, and we're going to get our interval. So we're 99% confident that the true population mean of grade point averages is somewhere in between these two numbers. Pretty simple. This is the only change. So what you should do for homework is page 316, 25 to 32. And I will give you the answers to the even ones, and I'll actually show them to you right here. I hope that you can see this nice and clear. Let me see if I could get this in here. Oh crap. I'm sorry guys, this is terrible. It might be too blurry for you to see. I could always send them to you too. But if you can see these answers right here, this is what your answers will be for those. And you're only going to do up to number 32. Don't worry about the other ones on the other page. And don't worry about these 22 to 24. They're based on other examples, and you have to go look up other data. So just do these from 25 to 32. You can do the odds and the evens. And then ask me questions if you have questions. I know your quiz is coming up very shortly, and I hope you do well on section 6.1. And I'll talk to you soon. We only got 2 quizzes left. So have a good afternoon. Talk to you soon. We're going to have our online chat on Thursday, same time as our class, which is 11 o'clock. So I hope to see you then. Bye-bye.